This is an RC forklift that can unload mini pallets from a mini warehouse or level up game nights by having forklift loading competitions. The best part though is that it's all 3D printed and made of DIY parts, meaning you can customize it in any way, or mod it in any way like I did with this motor swapped drifting forklift. So why a forklift? After all, we already have the skid steer and excavator which can be equipped with forks and do almost the same thing. Well, first off, if you've ever driven or been around forklifts, you'll know that they just have a fun, derpy atmosphere. Now, I don't know if that's because of the rear steering, which makes it feel like you're ripping the sickest drift ever all the time, Guido from Cars, or the entire forklift certified culture.
Yeah, mate, the forklift license. Easily one of the most powerful pieces of paper in the country.
From a practical standpoint though, forklifts in relation to skid steers and excavators are a whole lot more maneuverable in tight spaces, i.e. warehouses. Not to mention, in the latest poll for what piece of equipment should be next, forklift took the cake. Truck would have won, but the number of different truck types varied too much, with some being semi-trucks, pickup trucks, dump trucks, etc. I'm stoked about this, as after the crane project wrecked my world and took my lunch while I was down, I barely had enough brain power left to move my pinky toe. Step 1 of Protocol Mini Fork is laying out a 2D drawing of the overall dimensions. The main factor I took into account for this was simplicity. I want this to be a fun, easy intro project for people looking to jump into this 3D printed RC world. To accomplish this, I designed the body to form around the circuit board, which houses all the electronics. If you're new here, something to keep in mind is that these projects are all built like robotics projects, meaning a lot of the stuff you'll find here is the same stuff you'll see parading around a robotics classroom. For instance, this is an ESP32 development board, very similar to an Arduino microcontroller. The ESP32 acts as the brain of the project and is what's responsible for connecting to the plethora of different options you can control this project with, whether it's your phone, laptop, PlayStation 4, or Xbox controller, etc. To accompany the ESP32, there are supporting pieces such as the H-bridges, which are responsible for taking the signals from the ESP32, aka the brain, plus direct power from the batteries and making the motors move. These are essential, as if you tried just routing the motors directly to the development board, you would inevitably fry the board, as it's not meant to output that kind of power. The batteries I use for these projects and what I recommend to others are these Phoenix 16340s, because they come with a built-in charger, meaning you don't need any extra fancy charging equipment, but simply a micro USB cable. They have overcharge and discharge protection, so no need to worry about running the battery too low, and the best part is that they have short circuit protection so that you don't pull an electro boom.
Which is, I think, this.
With the body properly fitted around the electronics, I opted to place the steering servo underneath the ESP32, which will give us easy access to programming it in the future. For version 1 of the mast, I chose to use a 100mm threaded N20 motor to simulate a real-life hydraulic cylinder. The motion from the motor is translated to the carriage via thread, with one end tied to the main mast, the middle running up over the top of this pulley, which is placed on the end of the push rod coming off of the motor, and then finally the other end is tied off to the carriage. Which brings me to a concept called free lift. In relation to forklifts, free lift is the ability to raise the forks without changing the overall mast height. Now this is super helpful if you're unloading, say, a shipping container where you need to lift a pallet off the ground, but you also don't want to go ramming your mast into the top of the shipping container. Most forklifts accomplish this by having multiple cylinders, which lets them raise the carriage first, followed by the rear mast. For us though, that's simply not gonna fly, as to be reminded, the goal is to keep this as simple as possible, so I'm only permitting one motor for this movement. This animation on YouTube is what I based my initial design around, as it shows the push rod coming off the motor, just initially raising the carriage before running into the secondary mast and raising it as well. This seemed like a good place to start because there's still a moderate amount of free lift available, and it only requires the one motor. My first 3D printed versions of this were really flimsy due to only being connected on one side, but the concept seemed functional, so after a couple iterations I did have this success. But that's where the success stopped, as I had seriously overlooked the amount of travel the carriage had in relation to the pushrod. Now this is just a simple pulley problem, and here's how I currently have it set up. Our pulley is in the middle, and one end of our thread is fixed in place. If the pulley moves up 10 centimeters, the distance between where our thread is fixed and the top of the pulley, of course, increases by 10 centimeters, meaning we need 10 centimeters more of thread length on this side. Because the thread on this side is fixed in place, we have to pull it from the carriage side, which is also already being raised 10 centimeters. But now that it needs to add to our fixed side as well, it ultimately gets raised 20 centimeters. Now that was the wish.com version of a pulley explanation, so I hope it made sense. To determine the carriage's actual range of motion, we'll simply double the length of the usable portion of the threaded motor pushrod, which measures approximately 9 centimeters, so 18 centimeters of carriage motion. I designed the mast with the thought it'd be able to reach around 25 to 26 centimeters, so we're drastically undercutting our potential here. An easy solution is to add another pulley or two into the mix, which will increase our range of motion like so. As you can see, I now have 3 total pulleys in place, or an easier way to look at it in my opinion is 3 lines that will be getting longer whenever the pushrod is raised, meaning the unfixed side of the line where the carriage is attached will now need to cover a much larger distance to make up for those lines getting longer. I quickly rethreaded the mast and put it to the test. Aside from being a lot jerkier, it did indeed go higher, but I was now faced with even more problems. The first being, all the free lift of the original design was now gone. 2, due to the addition of more pulleys, I'm also now encountering more drag, which isn't mixing well with this thicker nylon string. 3, there's only so much room between the connection point on the carriage and the top of the pushrod, so we're still not reaching our full height capabilities. I did end up trying floss instead of that thick nylon, which was a big improvement, but alas, I'll need to keep scheming as free lift would be a nice feature to have, and the mast undoubtedly needs to go higher. Setting that aside for a minute, I started in on the actual driving / steering. This model will be front wheel driven via 2 and 20 motors. The wheels are pressed directly onto the motor and then locked in place via screws. Overall, this solution is really durable, and if something needs swapped, you won't have to remove a ton of parts to do so. Just make sure the motor is straight when you put it in, or else you'll get this weird wobbly noise. Grip has always been an issue when 3D printing tires, especially when only 2 of the wheels are powered, as is the case on this model. With the crane, I tried improving this by hollowing out the backside of the tire to give it some squish when rolling over objects, which did seem to improve the traction, but for this project, I think I'll take that one step further by expanding the inner edge slightly. Before, on flat ground, the sidewall would still keep the tire perfectly round even when weighted down, limiting the contact area with the ground, but with these slightly distorted tires, when placed vertically and weighted down, it ends up squishing that distorted edge flat, giving a larger contact patch with the ground, hence more grip. But there's still more work to do before we can fully test that in the real world. But for now, I'm really itching to add some more detail to this model, starting with the fenders. These always seem to add a lot of character to vehicles, and this mini forklift is no exception. By making them a pronounced feature, it adds a bit of a rugged off-road to the cartoony look, especially when some of the covers plus the roll cage are added in. This little guy really starts to come to life. Though to actually add some life juice, I first need to whip up some super cool
nerd code.
At this point, the code for all these RC construction projects is very similar, and the most challenging part for this project specifically was setting the correct percentage of power to each motor depending on how hard I'm turning. This is to aid in the model's ability to turn and not just solely rely on the rear steering. For example, if I crank into a hard right turn, the right wheel is on the inner edge, and by slowing it down, it helps to pull the left side around in a tighter circle. Now, don't ask me why I had so much trouble coding that, as it's really just some simple math when you boil it down. As for the rest of the code, I really prefer using this BluePad32 library, which lets you connect to the model via PS4/5, Xbox controllers, or a ton of other newer options. But if you prefer PS3 controllers, which connect differently, I also made a sketch for that. Just be aware that if you're using an Apple computer, it's a lot harder to obtain the MAC address off the controller. Finally, I also whipped together a Wi-Fi sketch that lets you connect via your phone, laptop, TV, or your Nintendo DS. This works because the ESP32 will function as an access point and show up as one of your available networks. Once connected, you can use your favorite web browser to enter the IP address of the ESP32, which will take you to the web page coded by yours truly. The page has sliders for the throttle and steering, and then buttons for raising and tilting the mast. From a phone, this is actually super controllable, and if you don't have a game controller on hand, nor want to shell out the extra cash to get one, it's a pretty good option. Controlling it via laptop, you can either drag the sliders via your mouse, though I'll admit that's pretty lame, or you can use WASD and JIKL to control it. One note, if you decide to go to the phone laptop route, is that you won't be able to trim the steering like you can from a game controller, which is done via the top two bumpers. So you'll either have to adjust how the servo horn is set or adjust the base steering value in the code. The second ability you won't have is the hard right and hard left steering option, which on the game controllers I have set to the triggers. This is extra handy if you're loaded down with something heavy, as it really lets you turn on a dime. Regardless of which controller interface you choose, I'll have step-by-step guides for uploading said code sketches to your mini fork in the workshop. Now, something that's a first on this model that I think everyone will be able to appreciate is that the power switch is now easily accessible right on the side of the model. Cutting edge stuff, I know. You don't have to open any covers or remove anything to get access to the power switch. But back to adding some more detail. I made and printed a seat with a grab handle as well as dual beverage holders because we don't mess around here at Boots Incorporated. That way you can fit an Arizona iced tea in the rear one and an 8-ounce Red Bull in the front. Not FDA or OSHA approved. Next, a little steering wheel, and then my personal favorite, a propane tank holder with a strap that makes swapping tanks easy peasy. Jokes aside though, swapping batteries on this is really easy as the entire rear cover just pivots back. Before iterating the mast, I decided to take the little guy for its first real world test. Steering and driving both work great. I ended up binding the mast to up and down on the right joystick, then the mast tilt to the D-pad. Any controls bound to the joysticks I make proportional, so if you move them a little, it'll move slowly, or if you move them a lot, they move quickly. Other than the mast being a little slow and buggy, the first test went pretty smooth. But slow and buggy is not what we're shooting for, people, so I scrapped the original mast mechanism, which entailed the hydraulic cylinder, and went for a winch style design. Instead of the motion coming from the push rod, the motor will pull in and out the thread via a spool. This is nice because I don't have the 9 centimeters of threaded rod limitation, but I still have adequate power. The thread from the spool gets wound over a pulley mounted to the top of the main mast, then to the bottom of the second mast, then back to the top of the second mast, and finally to the carriage. In the simplest terms, when the motor pulls in the thread, it closes the gap between the pulleys. So the bottom pulley of the second mast will get pulled up to the top pulley of the main mast, and the carriage will get pulled up to the top pulley of the second mast, ending in the shortest possible length of thread. Here's what that looks like in reverse when I let the thread back out. At this point, I hadn't yet figured out how to incorporate free lift into the design, though the solution did arise when I was testing it for the first time, and as much as I want to take credit for the solution, I'll tell you guys the truth, it arose by pure accident. Basically, I didn't tolerance my code enough to limit how far the mast could come back, so it was physically ramming into the body, which sounds bad, but because of this, it ended up jamming the second mast, preventing it from going anywhere, leaving the carriage free to move all on its own. Hashtag smooth brain solution. If mast height doesn't apply to your situation, you can simply run it without thinking about it. But if you need the advantage of free lift, simply pull the mast all the way back, which will lock it down and only let you raise the carriage. I ended up getting some super thin thread to replace the thick nylon with, which did improve the overall smoothness of the design. Floss still works great just as long as it's non-waxed floss. The waxed floss ends up sticking to itself when wound on the spool. In total, I tested 4 different options, and when put under tension, each produced its very own satisfying note. The 2 options I'd recommend are 1, this super thin nylon thread, or 2, the non-waxed floss. Fine-tuning the mast, I did have to problem solve why the carriage kept getting jammed every time I added more than a little weight to it. and I found out that 3D printed layer lines sliding past each other create way more friction than when they run with each other. For instance, just listen to the sound difference. When any force is applied and they're running past each other, it pretty much acts like a brake. This seems super obvious now looking back. To fix this, I redesigned things to be 3D printer friendly so the lines run with each other. For instance, instead of printing the second mast straight up, I now print it on its back. I want to note that at a certain point, you won't ever escape the friction generated by rubbing 3D printed parts directly on each other. But part of what makes these builds easy and simple is that other than the electronics and screws, everything literally is 3D printed, meaning no bearings or fancy sliders are required. I'm not against using them. For instance, whenever I do a bulldozer, I think I'll add some form of bearing just to help the track move a bit easier, since I'll intentionally be loading that model with a lot of extra weight. But on the forklift, if the carriage is still binding under heavier loads, you can always add a little bit of lithium grease, which should make it buttery smooth. With only a couple loose ends to tie up on the forklift, it's time to look into the actual warehouse. In the beginning, I had planned on completely designing my own setup, but after thinking that over a bit, I'm opting to use this warehouse system by WimV on Printables, as it's already the perfect scale. The second reason is that there's no need to reinvent the wheel, especially since he did such a great job on the initial design. 3, a fair number of people have already remixed parts that make it even better. For instance, these rack locks by Crab RC do a great job of taking what was a slightly wobbly model and making it skiddy or RC forklift proof. Plus, there's some fun additions of mini barrels and cardboard boxes for loading up pallets already available, which I'm hoping some of you who make this project will expand the number of 3D printable items to put on here. The only thing I added to the model specifically was a slightly smaller pallet option. Building out my mini warehouse, I opted to stick with the traditional color scheme, so blue racks with bright orange cross members. For the pallets, I used some of this Hatchbox gold filament. Loading down the pallets themselves with artifacts was a ton of fun. For instance, I have the original crane cab, old dump truck tires, a tennis ball, and even a mini off-road vehicle. Loading those pallets was, dare I say, therapeutic. I have my uncle driving in these shots, and it was awesome to see the level of driver progression that took place just over the course of a half hour. But in my opinion, where the fun with these models exponentially increases is when you have multiple in action, which is why in addition to the yellow one, I added green, orange, and blue mini forks to the loadout, officially forming the Forklift Power Rangers. I loaded up a total of 10 pallets and set 3 people free to practice. Once everyone was comfortable, we set out with one simple goal in mind: load all of the pallets onto the racks. Unfortunately, right as we were about to complete said goal, we had a bit of a sabotage from someone in our ranks, which turned out okay, as it ended up being a great team building exercise to re-erect the fallen shelving unit. To bring a little bit of friendly competition to the ring, we had ourselves a loading competition.
And touch forks. Okay, Ambi. What is it though?
Each person was responsible for 4 pallets and properly depositing them onto their respective racks. This was loads of fun, and I want the record to state that yellow was in the lead right up until this point, which is also when all the shenanigans began. The match ended in Green's favor, as he did help me flip my yellow mini fork back up onto its wheels, so congratulations Green, I suppose. Really quick, as a side quest, I want to try making a drag racing / drifting forklift, which really only means swapping these slower, high torque motors for fancy fast ones, which I got from a bot fighting company called Turnabot. As for actually building these models, I'll have the 3D files available for free on Printables, so you can print a couple test pieces and verify you actually like the design. Then to make it a fully functional remote control, you can follow this step-by-step guide, which can be unlocked by joining the Professor Boots workshop, linked below, or by going to professorboots.com. The guide goes over everything such as getting the circuit board made, soldering the components, uploading the code, and all of the assembly steps required to put this thing together. The workshop is the primary way I'm able to make these models, and I can't thank everyone who's a member enough. You guys seriously rock. But back to the turbocharged mini fork. I don't even have words to describe how awesome this thing is, so instead I'll just show you. Yep, that really did just happen, and if you ever doubted the durability, that's just with PLA parts. For the next build, I've made the executive decision to do a long haul truck, which will be able to equip a bunch of different trailer options. The question I have for you guys is what to base the truck design around and what trailer type to make first. So make sure to leave a comment down below with whatever truck model you want to see used as reference. Then of course, consider subscribing so you don't miss that build. Thank you all so much for watching. Now go chase those forklift certified dreams.